Hi there. Today's lesson is going to be over Chapter 12, Sampling and Statistical Theory. This is the second part of a two-part series on Chapter 12. Our next video will cover Chapter 13, so be looking for that in the coming days. Let's jump in. Today we are going to have two key takeaways from our lesson. The first key takeaway is that we're going to be able to identify the types of non-probability and probability sampling techniques. And the second key takeaway is I'm going to show you how to calculate an appropriate sample size for a research study. Now let's go ahead and get started. So a quick refresher on population versus sample, since we're going into these different sampling techniques. So our population is a much larger group, where our sample, we're going to take a much smaller subset of that larger group. So as a researcher, we want to get a very representative sample that's unbiased, and so a researcher may take this type of sample from that much larger population. So next I'm going to talk about all the different types of sampling techniques that I believe are most important for us to know. So the first type of sampling technique that we're going to talk about is the convenience sampling technique. And with convenience sampling, not everyone has an equal chance of being part of the sample. So it's only going to be those that are convenient for the researcher to access. So some characteristics associated with convenience samples are that the participants are easy to reach, the convenient sample is very quick, and it's also very economical for the simple fact that it's not going to take a lot of time and it's going to be easy to access the participants. So an example of this might be when a researcher is very close in proximity to the participants that they're looking at. So this could be like a student sample in the case of at a university. And so this might be a sample that the researcher chooses because it's very close in proximity to the researcher, very easy to access, and they're going to select the ones that are most readily available at the time of conducting the research. The next type of sampling technique is the voluntary response sample. And in this case, it's where people have chosen to include themselves in the sample or those that actually opt in. And this can present bias because those who feel more strongly about an issue or topic will choose to participate, whereas those that are not interested may not even care to respond to the research survey or interview or what have you that you're actually trying to conduct. So voluntary response can be efficient because we typically do this with like panel data. And the voluntary response, of course, you can see here there's more red in this sample, and that's because there's some type of characteristics that make those who are in that red subgroup more interested in this type of survey or research that's being conducted. So as I mentioned, panel data, whenever we're looking like at Amazon MTurk or like Qualtrics, they have where you can access panels and you pay to do this. And with that, in your panel data set, whenever you're actually obtaining your responses, those who choose to respond to your survey are going to be those who are more interested either in the amount of money that you're offering or in the actual topic itself. So that's why that would be a type of voluntary response sampling technique. So the next type of non-probability sampling technique is the quota sampling technique. And that is where various subgroups in a population are represented on some type of sample characteristic. And that's whatever the researcher desires. So in our case, we have divided this into the red subgroup, the black subgroup, and the gray subgroup. And so in this type of research, the researcher would have a quota to achieve for each of the subgroups that are represented. And with these different characteristics, what's important to note here is that quota sampling uses a convenient sampling procedure. So it's going to be those that are most readily available to the researcher, and then they're going to be easily found, and they're also going to be willing to participate in the research. So the various quotas that the researcher obtains are going to represent the different proportions of the subgroups within that population. So because there are a lot more individuals in the red subgroup, we would probably want to get 2 from the red, 1 from the black, and 1 from the gray subgroups. And the researcher in this case is going to select those that are the most readily available in proximity or in ease of access. So in our case, it would be the S and the L in the red subgroup, the F in the black subgroup, and the G in the gray subgroup. Our next sampling technique is the snowball sampling technique, where research participants recruit other participants for a research study. And with snowball sampling, you would have an initial set of respondents that you go with. So that would be represented here where we have our initial set of respondents. And what next occurs is that they go and give referrals or recruit others. And that's the whole basis of snowball sampling. The reason why it's called snowball sampling is because in theory, once you have the ball rolling, it's going to pick up more snow along the way, and our sample would become larger and larger over time. And so with that, it's going to reduce our cost, but with any type of non-probability sample, there is the potential for bias to enter in to our research study. But to give you an example of how this might turn out, as a researcher who's gone and asked our initial participant pool in this circled area to go make referrals as these arrows represent, a final pool of our sample may include these individuals here. So snowball sampling can be a very effective technique whenever you have a very hard to find population of interest. Now we're going to shift gears to probability sampling techniques. The first and most common of the probability sampling techniques is the simple random sample. And with the simple random sample, this assures that each element in our population will have an equal chance of being included in the sample. So you could think of this as if everyone in the population was given a paper with a letter or number on it, and then we place that letter or number in a hat. The number of participants that we want in our sample could then be selected from the hat. So, for example, if we wanted a sample size of 6, we could select 6 papers from the hat, which could generate a sample such as this, where we then select those participants from that population, and we could also use a random number generator to randomly assign a number to members of the population, like members of our class, for example. And then we could use a program that would allow us to randomly select members of the population for the sample based off of the number for your sample. So this could be like 6 participants. The random number generator would generate all the random numbers for the different people in the population, and then the random number selector would select the 6 numbers randomly from the entire population. The next probability sampling technique is the systematic sampling procedure. This is where members from a larger population are selected according to a random starting point, but with a fixed periodic interval. This interval is called the sampling interval, and it's calculated by dividing the population size by the desired sample size. So in our case, we have 20 individuals in our population. So we could say that we want a sample size of 5 from our population. So we would need to select every 4th person, starting with a randomly selected letter here in our population. Now, a randomly selected letter could be L. So from L, we would select every 4th person. So we would select the P, T, D, H, and L. And as I'm sure you noticed, once the end of the list was reached, once we got to T here, we actually looped back to the start of the list to finish our count. And we could also do this through membership directories, telephone lists. There's multiple ways that you could do systematic sampling, not just this basic example like I showed you, and they are done very often with member directories and telephone lists for a particular geographic area, for example, or based off of some type of predetermined criteria, like the membership directory. Maybe it's to the American Marketing Association. Our next probability sampling technique is the stratified sampling procedure. With this, you have stratums, where these would be different groups, different subgroups, and these different subgroups would represent a strata. And the strata is where you have multiple stratums within the strata. So what is going to be done in a stratified sample is random subsamples that are more or less equal on some type of characteristic are drawn from within each stratum of the population. And so this represents our simple random sampling procedure that we would do for each of the stratums. So for example, to get a sample of 6, we could take a simple random sample of 2 from each stratum to get our sample size of 6. However, this would result in a disproportional stratified sample because there are a much larger proportion of people in the red subgroup than in the other 2 subgroups. So to achieve a proportional stratified sample with 6 in our sample, we would most likely need to get approximately 3 from the red and 2 from the black and 1 from the gray, as gray represents the smallest proportion in comparison to the red subgroup. So the last thing I'm going to show you is how to calculate a sample size. And with calculating a sample size, you need to know 2 key things. The first is the confidence interval, and the confidence interval is also called the margin of error. It's the plus or minus figure that's usually reported in the newspaper or television opinion poll results. So, for example, if you used a confidence interval of 4 and 47% of your sample picked an answer, you can be sure that if you had asked the question of the entire relevant population, that between 43% and 51% would have picked that answer. The next key thing that you're going to need to know is the confidence level. And the confidence level tells you how sure you can be. It's expressed as a percentage and represents how often the true percentage of the population who would pick an answer lies within the confidence interval. So we often hear like the 95% confidence level or the 99% confidence level. What that means is for 95% you can be 95% certain. For 99% you could be 99% certain. Now most researchers, they use the 95% confidence level. And whenever you put the confidence level and the confidence interval together, you could say that you are 95% sure that the true percentage of the population is between 43 and 51%. Or you could use a more generic statement, which could be at the 95% confidence level, this study has a margin of error of plus or minus 4%. Now, the wider the confidence interval you're willing to accept, the more certain you can be that the whole population answers would be within that range. So, for example, if you asked a sample of 1,000 people in a city which brand of cola they preferred, and 60% said brand A, you can be very certain that between 40 and 80% of all the people in the city actually do prefer that brand. But you can't be so sure that between 59 and 61% of the people in the city prefer the brand in that case. So whenever we're calculating sample size, this would be the formula that we would use if we were to do it by hand, but we're actually going to calculate it with an online calculator. It's very simple, and I'll put that online calculator link in the description of the video, so be looking for that. And you need the desired confidence level, either 95% or 99%, and then you would also need the confidence interval that you're planning to use, the margin of error. So you would enter that without a percent sign, and then you would also put in the population size. If it's not known, you just leave it blank. Typically in our case, our population size is going to be very large because we're looking at consumers, or in the case of B2B, our group our population that we're hoping to really get some insights about, it's going to be relatively large. So we would leave that blank, and it would allow us to calculate the different samples based off of our different inputs. Here are some examples from that online calculator, and you can play around with it. I encourage you to go on to the website. It is provided in the description of this video. The link is, so you can go on there and actually play with this yourself. I've included some different scenarios, put the calculator at the 95% confidence level, done a 3% confidence interval, and shown you that the sample size needed here is 1067, but if you doubled your confidence interval to 6% here, then your sample size would almost be cut by 3/4. All you would need is 267 in that case. But if you went up to the 99% confidence level, that's where you're going to need some more participants. And this is even at the same confidence interval that we just did previously up here. So at the 99% confidence level, you would need more participants. Whenever you increase your confidence interval, you would need less participants. So that's just an example here. So our next video is going to be over Chapter 13, Big Data Basics, describing samples and populations. If you have any questions, feel free to reach out to me at kt.manus@ttu.edu. Thanks. Bye-bye.